Good morning. I'm Antoaneta Ivanova from the University of Telecommunications and Post in Sofia. In the next 10 minutes, I will show you a digital twin that couples the technical and the financial sides of gas distribution, and I will keep it in practice. For 4 years, I have worked on tariff submission with Bulgarian gas operators. Every time I saw the same problem. The engineers model the pipes, the finance team models the tariff, and nobody connects the two, even though the tariff formula requires exactly that connection. The gap is expensive. Across the regulatory cycles, the forecasting error on commercial demand is about 40%. That is not a bad year. That is the baseline, and it translates into a real losses in the next tariff period. The paper delivers 3 things: an architecture that a small operator can actually run, a method that couples the physical and financial sides, and validation on 4 years of real data. The picture shows how it works. On one side, the network, on the other side, the digital twin. Data follows in from SCADA. Decision and the reports follow back out. 4 components: a physics engine, a tariff engine, a forecast layer, and a validation layer. Simple, modular, testable. The physics side computes pressures and flows throughout the network. It uses the standard low pressure equation. You can see it on the side. No need for me to read it out. The relevant output is a single number: how much gas is lost in the network. The number feeds the physical side. The financial side implements the EWRC, allowed revenue formula. Again, on the side, no need to read it. What matter is it? The network losses from the previous slide feed directly into a revenue formula. That coupling is what commercial spreadsheets do not do. And that is what makes the whole approach work. A forecast should not be a single number. It should be a range. So I run 1,000 simulations. Each one draws a plausible demand, runs it throughout the network, and produces one draw of the tariff. The result is proper distribution with a proper confidence interval. 4 minutes on a normal laptop. The case in Costinbrod Gas, a regional operator near Sofia. Median size, mixed customer base, 4 years of records. I pick it not because it is the best, but because it is typical. A median case tells you the framework works on the most of the sector. Here is the headline result. Forecast error drops from nearly 40% to about 9%. On the chart, the red line is the twin. The blue dashed line is classical baseline. The twin tracks reality closely, especially throughout the winter peaks. 5 stress scenarios. From the mid-season, a gas price shock. Revenue can move minus 10% in a recession, but 22% in the shock case. Both bounds were confirmed as realistic by the operator's management. That external check matters. This table lets you see the improvement across 4 methods. Every column improves at the same time. Forecast error down. Confidence interval compressed 3.5 times. Directional accuracy up from 50%. A coin flip to 78. Economic coupling is doing real work here. 3 points to take away. First, the twin accurately predict the direction of the next tariff move, not just its size. Second, revenues see the uncertainty, not just a pointly estimate. Third, the operator confirmed the stress test bounds. Model and management agree, which does not happen often. Limits. The formula is assumed stable. 4 years is a short window, and this is one case. Next steps, climate-sensitive forecasting, pilot with 2 more operators, and coupling with the organizational maturity paper I present next. Conclusion. To wrap up, the twin closes a gap the small operators have always lived with. Error down from 40 to 9%. Confidence interval tight by a factor of 3.5. Directional accuracy up to 78. And it is produced and artifact ready to be filled with a regulator. One last note, a tool needs an organization ready to use it. That is why my second Agora submission, the maturity framework, is the natural companion to this one. Read them as a pair. Thank you. I'm happy to take questions and to discuss how this could apply in other regulatory contexts. The data and the notebooks are available or on request.